Welcome to Container Days. Thank you for so much to joining me at this Understanding Zero Trust Security session with Service Mesh. And in this talk, I'm going to be talking interesting things about security that you probably didn't know. And I will start with the concept of explaining concept of trust and why zero trust is actually a better thing for your security system than trust itself. Usually, when I start this conversation, people are saying, "What do you mean by zero trust? Isn't the trust good thing? Is it something that we want to have trust in our systems?" And the answer is, well, let's break this down. Let break this down and talk about what makes it a good thing or a good idea. So we usually were taught that the trust is a good thing, that you can trust to your relatives, to your friends, to your colleagues, some of your colleagues. And uh, I want to bring some of the examples of the trust and how this trust was exploited. So this is the elements from the Lion King movie. And Mufasa thought he can trust Scar. Simba thought he can trust Scar because he thought it was given because he was a part of the family, he was relative. Now we know how everything turns out. Trust is exploitable. Trust is something that someone can use in order to penetrate to the system and do some harmful things. So we must eliminate trust to achieve security. And there is a reason why trust was exploitable. We're gonna do remove the trust. We're gonna do something better, and we're gonna be focusing on some of the tools that allows you to eliminate trust and make things better in your system. My name is Viktor Gamov. I work as a developer advocate at a company named Kong. At Kong, we build tools and different things that allow you as a developer to build your systems more reliable, more secure. And today I'm going to be focusing some of the things into the tool that we built at Conk and open sourced it and moved this into CNCF sandbox. It's called Kuma. Kuma it's the control plane for Service Mesh, and I'm gonna dive a little bit deeper here. But before that, let's talk a little bit more about security and what kind of the pillars we want to talk about when we're talking about zero trust. So zero trust essentially it's a big topic to discover. It's a big the concept. There's a lot of things come into zero trust practices. So it is a set of patterns. You cannot just come to any vendor and say, "Hey, can I buy this zero trust thing from you?" Zero trust, again, it is a set of patterns. And today I'm going to be focusing on 4 pillars of zero trust. There are more of them. And if you will be researching this topic or you will be representing or be attending some of the presentation for other vendors, you might notice some of these pillars there. So, but today I'm going to be focusing on 4 things. First thing is identity, how and what needs to be serve as your tool or some of the ticket or something, how you can identify the systems in distributed world. We'll talk a little bit about automation because of the when you remove some of the manual steps along the way, it will help you to achieve security because you're not relying on a human factor, you're not relying on some of the manual movements and things like that, right? We're gonna deny everything by default. So when we're removing trust, we cannot trust to anyone, even though we're running to the systems that run in the same network or running in the same data center or in the same office and things like that. Zero trust will remove any guess from here. So we need to deny everything by default. That's going to be your mantra in general when implementing these zero trust patterns. And things that happen in your systems needs to be easy observable. So this is the 4 pillars that we're going to focusing today. Yeah, let's jump right in. When I travel, I found the the concept of the border patrol officer is a very good illustration of my first thing that I would like to talk about today, about identity. And when I travel different places, unfortunately, I cannot travel this time to Hamburg, but maybe next time. But when I travel somewhere, I need to cross the border. So in one place, I'm going to some other place. How I can identify myself as a person that not, I make sure many of you who listen to this presentation or attending this conference you don't have any criminal intent. However, there are some people who have criminal intent, and how I can prove that I don't have this intent. So, how I can prove myself, and they can compare me as a person that presents in the front of him that I am who I am, and based on the certain information that I can provide, how they can make sure that I don't have any criminal intent or criminal background and things like that. So, in order to introduce, I can basically tell to this the border officer said that I'm not the bad guy, and he will trust me because why wouldn't he? However, it is not happening in real life. We need to have something to identify myself. So we're introducing form of identity so we can remove the trust. So in this case, it would be yes and no. It would be always deny or allow a type of conversation. So there's no given trust. And for that, what we're using some sort of multipass or your passport or whatever to identify yourself. Little dollars multipass. So when we're running our systems, when we're running our microservices, we need to come up with some sort of idea of multipass for our services. We need to get something in order to, or attach something to request or some sort of like API call that will identify us, and external system will make a decision if it grants us access to the system or will deny this access. So let's talk about microservices. Typical microservices application, marketplace application that has some user service that stores information about users. It has information about the service that will be serving information about inventory, and some other services. Invoices, blah, blah, blah. So multiple services can interact to each other. When this application was monolithical, everything was much better, much easier to control. Everything was in one place, and we could use tools that provided by our platform. It can be JVM, it can be any type of runtime that provides you with some sort of isolation. You can use encapsulation to allow access to the certain systems. You can implement some sort of entitlement system that would put additional layer of security for calling certain methods like users. Service can create users, and user service can find particular users, and everything can invoke everything except if you make some methods private, you will not be able to call them, and so far and so on. Things got a little bit difficult when we moved things into in the microservices world. Like everything is microservice now. With this, we now have a network call, and there's multiple things can go wrong during this network call. So first of all, this call going over the physical network, physical wire, and we need to make sure that everything goes over this wire. Will have secured connection. So in this case, maybe even encryption of the traffic, actual bytes. Next thing is that how we can prove that when we're calling this in the voices service, we actually allowed to do that with the and this goes a little bit higher on the level of security. So where we have a network call, we can encrypt this and provide a mutual TLS certificates, and we will make sure how our services will interact. Now, in the mutual TLS, we also need to make sure that we will have some sort of authority that will be issuing the certificates for our systems. In example, with border control officer, there would be some government agency that will issue my passport. So here we also will be dealing with the similar situation. And also we need to make sure that actual data that we're calling will be allowed. We're allowed to do this type of things. So with in the past, we can use something like IP address as our identity. We can have some sort of allow, deny lists with a set of IP addresses that we will, or host names that will allow access to the system, or we will deny access to the system. However, it is not that easier. It is IP address becomes a very bad form of identity very quickly when you're running things into some sort of containerized systems. For example, you're running this in Kubernetes, and IP address is no longer valid and good identity tool. So we need to come up with something better. So it turns out that it's already some sort of this situation already solved in a world of TLS. So there is extension for TLS called a subject alternative name. So you can put the names, different names for particular object that needs to provide this identity, and SAN. It's something that we can embed in the certificate when we're going to be issuing this. So certified authority will provide us with this form of identity in the form of DLS SSL certificate, and there will be special information, the subject alternative name, that allows to make sure that this particular the service that certificate was issued for will have some sort of alternative name, and we can validate against this if we can get access to the system or they cannot. So it's all nice and cool, but you need to implement this yourself. So managing certificates, it's not a difficult task. However, it becomes very tedious and boring if you need to do this and repeating yourself all the time. Things like rotation of certificates, issuing new version certificates, rotation of the certificates over the time, watching some of the certificates will expire, and things around when there's some of the breaching, some of these certificates might be considered as a compromised, you need to reissue new certificates. All these things are not difficult to do. Again, I'm repeating, it's not difficult to do. However, it will require some additional human interaction. It will require additional the person to take care of those. So in this case, we're going into the second pillar with the automation. And this is where the concept of service mesh actually start bringing some of the interesting results. So first of all, what is service mesh? Service mesh contains two components, and the relation here is one to many. Service mesh contains some of the agents, or how we call it, data planes, some of the agents that runs next to your application. And remember, that's our user service, item service, and voice service, and whatever. Those services will include the small agent that we call data plane. So what this agent will be connected to something that we called control plane, essentially the centralized entity that will be providing controlling and configuring capabilities to this data plane. So all the traffic, all the interactions of this system will go not direct calls, but through these small data planes, also known as proxies. So those proxies will handle all the traffic based on configuration that system administrator or a mesh operator will be providing. And these policies will be invoked. And the cool thing, all these things can be automated and can be declaratively configured. And this configuration can be stored in version control and using tools around GitOps. All those things can be automated. So you will always have a history of the changes, what happened with the system, and how those things were applied, and including things around a enabling certificates, creating like certificate authority. So this control plane can be a certificate authority that will be issuing certificates, and through the through a configuration protocol, those information will be shipped into data planes. So few words about Kuma itself. It's one of the implementation of service meshes. There's a plenty of other technologies that are available and also implement service mesh pattern and have a very similar capabilities. Few notable things about Kuma and why it was developed. So Kuma provides a very straightforward ways how you can configure your system. So the policies are very concise and very straightforward and easy to understand. It will require Kuma is not required to be run on one particular runtime, so that's why we call it a universal service mesh. So there are technologies and there are service meshes implementations that were designed solely to run, for example, on Kubernetes. But we know that a world is not only evolves around Kubernetes, even though it's kind of fun thing to mention during container days, even though many people probably will use Kubernetes. However, many people still run a lot of stuff, maybe separated containers without running on Kubernetes. We can run this in Docker separately or some other container runtime, or we can even run our application still in bare metal. Service mesh will be able to work that. And the cool thing is that configuration policies are would be easily translated. So the configuration language will not change except in Kubernetes we'll be using customer sort of definitions and the things outside of Kubernetes, like bare metal and VMs, we're going to be using some sort of like API call. And in many cases, deployment strategy is also not bound to one particular data center. So that's why Kuma has great capabilities for building multi-zone connectivity, multi-zone service meshes that allow you to basically connect multiple data centers. You have a one mesh in one center, another mesh can be even in different cloud, and through the universal multi-zone connectivity and universal global control plane, you will be able to manage all this connectivity. From perspective of architecture, control plane runs as a standalone instance of the process and stores information in some sort of database for the reason of configuration, having this configuration in one place. And after that, this configuration will be sent down to many other data planes. So Kuma uses this project called Envoy, which is a CNCF top-level project right now, and talks to Envoy through Envoy configuration protocol in order to configure those data plane proxy. So example, Kuma can generate a certificate and can send those certificates. So those certificates will be running next to this data plane, and connection between the services will be handled through connection between two data planes. We have many examples where the people are running Kuma across multiple data centers across the world. So the multi-zone is the great piece of functionality that these days is becoming more and more important. And the global control plane can have one place to rule them all, and literally you can run multiple instances of service mesh across multiple different platforms with one global control plane configuring how the traffic will be flow from one place to another, including configuration. So this is where the service mesh is handled a automation out of the box. So controlling what kind of policy and how the policies will be rolled will be handled by the service mesh. So the things I was mentioning in the very beginning, that the control plane not only provides the essentially configuration or service discovery capabilities for the services, but also it provides the ways how like MTLS certificates would be rolled. So Kuma has built-in certificate authority that can generate certificates and send the certificates to different certificates to the different data planes, where it also will keep them up to date, and will check the expiration if the expiration will expiration time come into play. It will just go and roll new services. By default, this is we're going into kind of like a third pillar where like you deny everything. We just like with one policy, this policy has allow all traffic, so we can say everything from everywhere can go, and all the services can communicate to each other. With the same configuration change, we can implement disable all. So essentially, we need to disable all the communication between all the traffics just with one policy. Now, from perspective of more or less how it's called more granular entitlements based security, we can implement so-called open agent policies that allows us to use this open agent policy to implement some sort of logic in terms of what we can allow to call and whatnot. So in this particular example, we're going to be introspecting JOT token that will be included in the request, and we will make sure that it will contains required information, so it will include it inside the HTTP header for authorization, and has correct token that we can read and validate, so and make sure that when the call comes in and the token includes the valid secret information, we will be allow this configuration. Now, with zero trust security, how you can achieve this? This can be easily achieved by design, by implementing this as a part of your service mesh deployment. Service mesh automatically provides you with the MTLS encryption. You can enable this just with very simple configuration change. And the cool thing about Kuma, when you logged in into user interface, Kuma will provide you with kind of recommendations what to enable. It works for any type of API. So it works for REST calls, it works for gRPC calls, TCP calls, and all these kind of things. It works. Next, so we can implement a compliance on with implementing, like, disabling everything. So deny everything type of pattern, and after that we bring a granular access to certain systems, so you know that your user service will be able to access inventories, and user service cannot get access to billing, and you can disable this on the traffic on the network level. So you will be able to have a policy that proves that yes, this service is not have access to, to another service. And this is something that you will be easily it can be easily detected through service mesh tools. All this information also exposed through the metrics and through the UIs that you can say populate your Prometheus and Grafana with all this information, and those information will be populated in the real time. And with the tools that automates all this, including global control plane, including multi-mesh situation, your security central team that can very quickly roll all these policies preventing one service to access another service. So because you will have a tools to automate the infrastructure, you will have a tools that automate the process of network communication of the systems, you will be able to easily access to you will be able to in a real time change network policies without or disable some of the accesses that allows you to quickly introduce like security patches and things like that. Now, we talk a little bit about identity. We are relying on the SAN extension in the certificate. Service mesh provides the way how we can automate the policies rollout. By default, just go and disable all the traffic between all the services, and after that, allow the granular access. And through the observabilities, because all the traffic that goes through these data planes and goes over one system to another can be captured on the data plane side of things, and data plane will report to say Prometheus, and Grafana can be used to visualize it. You will be able to see in real time how your system will be behaving and what kind of policies are available. Now, for the demo, I have already a pre-recorded demo that also available on Kong YouTube channel. You can use this code and go and check this out yourself. This demo will include example where we can prevent some of the typical example where you have some of the containers that you use in development and you forgot you also rolled out in production, and how you can prevent this container to get access to production data. So check this out with the separate thing. So it's a beauty of having the virtual conference that you can grab these things and watch on your own pace. And there's a few resources that I really want you to check this out. I on the Kong YouTube channel, me and my colleagues from Kong, we're trying to kind of like go live every other week and talking about tools that we're building. We call the show Kong Builders. Subscribe to YouTube channel of Kong, youtube.com/Kong Inc. and join the Kong community if you're interested in all things API connectivity, cloud connectivity, and all this nice and fancy things. So my name is Viktor Gamov. Feel free to follow me on Twitter and ask any questions about all this the technology, service mesh, API gateways, Kubernetes, cloud native. I will be happy to point you to the right direction. And with this, again, my name is Viktor Gamov, and as always, have a nice day. Enjoy Container Days, and hope to see you next year in person. Take care.